Okay, then we will welcome Anton Maertens on link from Belgium. I believe you are in Belgium still, or now?
Yeah,
Yeah.
yeah, definitely
Yeah.
in
So
Brussels
he's
now.
a business developer at BC Materials, working with circular economy and climate change issues. And
Yeah,
they're a great resource in working with excavated clay, using resources
thanks.
that other think of as waste. So
Yeah,
yeah, great to listening to you. Welcome.
yeah. Hello, everyone. I'm a bit sad that I'm not there. I would have loved to join, but I'll try to give a decent presentation while you're enjoying your cake. So here it goes. For us, it's a very simple statement: Earth as a solution for Earth. Because the theme of the seminar is nature-based solutions, and actually Earth is one of the most basic nature-based solution that we can find in building. But let me first sketch a bit the problem that you probably know. Yeah, the building sector is one of the most polluting sectors in the world, probably the most polluting. This is a building here in Brussels that was demolished after only 30 years. And unfortunately, it still happens a lot in a lot of cities that all of these materials are not selectively dismantled, but just demolished. And so the building sector causes a third of all waste globally. It's also responsible for 40% of CO2 emissions, both heating and 10% upfront carbon. This upfront carbon is what is CO2 emissions based on the production of these materials. And also important to mention that it's responsible for 50% of extracted resources. So it's a very heavy weight on the extraction, on the sourcing of materials. And if you would put it a bit more boldly, you could say that, in fact, with the new EPB restrictions, one can now build a new house that is entirely reliant on renewable energy, which is great. But actually, all the emissions that we will cause with new buildings in Europe are actually tied to how you produce these materials and not necessarily by the building operations. So it's really a new challenge that we have to tackle, the CO2 emissions related to building materials itself. And there's still a lot of quick wins or a lot of low-hanging fruit that we can win. This is a graphic from Rambo Consultancy that you probably know better than I. In fact, a lot of people see that if you have a square meter of building, that it's approximately equivalent to 810 kilo of CO2, an average building, and that the best practice could be 344. I think if you would start to calculate a number of bio-based elements, that could even subtract even more of the best practice. But there's a huge reduction possible, and it's really something that we should be able to apply in the next 10 years in a massive way. And this graphic I also like to show because it's quite shocking. I think that we're at this phase in humanity that we've actually produced more waste than nature and everything that is bio-based, plants, trees. We've actually surpassed producing more man-made material than nature has over thousands of years, and it's quite hallucinating that we are using so much concrete, so much bricks, asphalt in our everyday construction life that it's actually surpassing what nature has done over all these decades and hundreds of years. So we need to change our shift, change our gear, and nature, I think, is an interesting mentor there. And that's why we think that some of this waste, and excavated earth is considered as a waste, should actually be seen as a building material. And this is what we do with BC Materials. We transform excavated earth into building blocks, like the 20,000 blocks we made for an eco class in Antwerp. These 20,000 blocks was one of the first projects of both BC Architects and BC Materials, but there is so much excavated earth, both in Belgium and in other countries around us, that it's really a waste to not valorize it. We work like this, that we can, when there is an extraction, and you know this, when there's a construction going on, Usually for a foundation, a parking, or a cave, there is a number of tons of earth that needs to be excavated. Usually that transport goes to a temporary stock and then it becomes landfilled or dumped into mines or quarries. In Belgium, it sometimes even has to go to the Netherlands or Germany because we simply don't have the space anymore to take care of this excavated earth. So we kind of intervene in the transport by producing in Brussels blocks, plasters, rammed earth with this excavated earth instead of just casually throwing it away. And so our mission is really to make the construction sector as circular, sustainable as possible, and really specifically for us to turn this kind of niche of earth-based materials into something that is mainstream and at the standard, and that can really grow for a lot of people. This is an example of our earth-based plaster. We show it because it really has practically no CO2 impact. It's actually almost CO2 positive because you have a lot less transport. You avoid transport of excavated earth, for example. And it's just not ecology, but it's also quality, I think, for people who live inside these buildings, because it's better for air quality, better for your acoustics, better for the humidity. And also, and this is becoming an argument that in Belgium and a lot of Western Europe becoming more important, is that it's mitigating temperature. And a country like Belgium that is quite humid and that is quite cold in winter is becoming a bit more Mediterranean. So we see that we really have to prepare for a more warmer summer, sometimes with pernicious heat waves of more than 7 days where it's 30, 35 degrees. And really, people in Belgium are not used to this. So if we all start to install air conditioning, we'll just worsen the problem. So we really have to see how we can use nature as a kind of mentor. And I think earth-based materials cool automatically a space with 2 to 3 degrees, and it's really very helpful in these kind of in this kind of departments where you have heat waves and the negative consequences on our health. You probably also know rammed earth. Rammed earth is a technique where you mix gravel, sand, and clay. And it's a kind of concrete, but an ecological concrete where you mix it and you kind of ram it, and you can make quite high structures with this. This is an example of both the wall, one of the biggest rammed earth structures in the Benelux, and Negenoord, which is a belvedere, a watchtower that we made based on excavated earth of the site, and that we built together with the contractor to have this structure finished, an architectural project by the Houden Lineaal. And the blocks I really want to mention specifically because we see really as a large potential there. These blocks we made for one of our first projects in Edinge, the bioclass. And here you can see in quite an artisan way that we make these blocks almost manually with some good machines, but still manually, at about 1,500 blocks per day. But it's now possible to make these same blocks in an industrial level by using existing infrastructure of concrete producers or baked brick producers, but inserting our formula into their scheme and not baking the blocks, but pressing them or vibro compacting them. And in this way, you can accelerate your production rate from 1,500 blocks to 60,000, 80,000 blocks per day. And in this way, you can really decrease the price. It's really one of the deal breakers in a lot of architectural projects is that ecological materials are usually a bit more expensive than others. And I think this is a kind of industrial symbiosis way of decreasing the price and at the same time really being able to mainstream your material. Just to give you an idea, in Belgium alone, there's 1 million tons of internal block work. As you probably know, a compressed earth block, you cannot use it for outside blocks. But as you can see by this number, there's such a big demand for internal block work that could be filled up with earth blocks, that it's really something that you should press for. And I think it's probably also possible in Scandinavia to go towards this industrial symbiosis where you use a kind of decarbonized way of producing something that is not necessarily baked and that can really do the job of any kind of block within the building. We call this material reach leem, from the Dutch word and also the German word, and it's a whole reach of different materials, plasters, fine plasters, also netting, blocks, and ram dirt. And we've been growing a lot lately because we started in 2019 with this approach of making earth-based materials based on excavated earth. We started with about 50 tons, and now last year in 2023 we reached 2,000 tons. And there's some questions also from abroad, from Luxembourg, from the Netherlands, to do this kind of projects with our materials too. We also do a lot of workshops. This is now a specific workshop on hempcrete that you've seen here, but in general, we see that this is one of the bottlenecks to try out new materials, to try out earth-based materials or bio-based materials, is that a lot of contractors don't know how to use this material or apply it, and that's unfortunate because it's a roadblock towards the uptake. And in this way, I think by organizing workshops, you can really remove that roadblock and make the contractors feel empowered and less scared about using these materials. We also have some new products in the pipeline. We recently launched a paint based on excavated earth. It's really shocking, I thought, to see what kind of rubbish and what kind of garbage classic paint producers put in their paint. There's a lot of microplastic in, there's a lot of solvents in, really chemical stuff that is bad for the health, and that is a bit kind of like waste leftover of the chemical industry that is being put into paint. And so we decided to really make an as healthy paint as possible based on excavated earth. And the colors come from the clay that we use. It's also with screed coming, a screed non-cement based, but earth based, that you can pour, as you can see here on the picture, as you do with any screed. And it is decarbonized and reusable at the end of the line. This is some examples of the paint that we launched recently. You also see some ram dirt design pieces on the right picture or on the left picture. I also wanted to mention we work mostly in the Benelux. We feel that it's better to stay within limits of 250 kilometers for resource use, because once you kind of exceed this resource use, you kind of lose the ecological advantages that your material offers. We get a lot of questions, even from Australia and New York, for our samples and for our material use, but we kind of refuse these questions because it kind of annuls all of the ecological advantages that our materials would have. But we always are open to consultancy to see how we can make the earth building material world bigger in other countries, how we can exchange information, and how we can transform these materials together with partners in other regions. Obviously, the best part, and I think that's really where you get the inspiration from nature. Nature doesn't waste. We shouldn't waste either in the construction sector. And it's great to start combining stuff where you see that what is already present in the city, an existing structure, steel beams, that you can reuse those ones, and at the same time use bio-based insulation like straw bales, hempcrete blocks, like is used in this project. And I think it's a really cool project because it's in Brussels, an extension of a building, but it has everything. It has ram dirt, clay plasters, straw bales, hem blocks, and reuse of radiators and a number of other materials. And you get to this kind of almost excellent exemplary combination of materials where both the health of the inhabitant and the externalities are completely, where the health of the inhabitants is excellent and the externalities that materials normally cause are completely abolished, because all of these materials can be both reused and didn't have any negative effect when they were produced. This one you probably know. We see that with renewable materials, regrowable materials, bio-based insulation, we could really become a carbon sink in the construction sector instead of a carbon emitter. And it's really very compatible with all earth-based materials, because you can plaster cork, you can plaster hempcrete and straw bales, combine wood structures with compressed earth blocks to create the mass that is necessary in the building. There's really a lot of stuff possible. And this is also a bit why we're moving towards a new direction in the upcoming years. Currently, we're producing on 1,300 square meter production space in the center of Brussels, not far from the center. And this is already great for us because, as I mentioned, we're seeing the growth, but we think that this combination of using both bio-based and geo-based and resourced urban-based materials is really a big idea that could really change the construction sector. And that's why we're moving in the near future towards a different site, actually on the other side of our street. And we're doing this together on a bigger scale with our colleagues from BC Architects, Democo Group, who is a contractor that is focused on reused material like steel beams and certain insulation. Tournevis, Natura Mater, local Sonian Woodcoop, that is a local wood producer. And Nean Partners WOW, who is a circular CLT reuser. Instead of most of the CLT that is produced, some of it, 7 to 25%, is waste and is usually transformed into pellets. And they want to start reusing these CLT leftovers. And it's this combination of partners with which we are going to build a project, an exemplary project for these materials, but also focused on mainstreaming the circular transition in the construction sector by acting on production, distribution, training, and innovation in these materials. The focus is obviously on the Green Deal, where we should have a Europe that is completely circular and CO2 neutral by 2050. But we also like these values from the New European Bauhaus with inclusivity, beauty, and we think all of this is really possible if we let nature guide our part of our architectural insights and design. And it's really smart to make it not only into something that is construction based, but also cultural based, because I think this new approach really taps into what young people want and what is precious, what is not wasteful. And in the end, and I'm really eager to hear your thoughts about this, I think there's a lot of win-wins in this approach, because we're going to win both on health, on creating good jobs in the city, on collaborations between industries, fighting climate change, and really managing a more livable city and a livable future for a lot of us. And that's it for me. I hope I didn't go too long over time, but I'm eager to hear your questions.
It was excellent. Thank you. You had 1 minute left. Great. So maybe how should we do with questions now? We take it later. Still, will he be able to listen in? Should we take one question now? Yeah. Any question? Yeah, Rosa.
Hi, Anton, thank you so much for your presentation. I was wondering if you could tell us a little bit what were the changes you had to do to the mixture once you decided to scale up and to go to the industrial level? How does that compare to the kind of more, as you said, artisanal way of doing it?
We didn't have to change that much to the composition of the materials, but we really have to be close at hand when the industrial production happens. So we do a premix here in Brussels, and then we can take this load by boat towards our industrial partners, and they can produce there on the spot. In the beginning, we thought that it wasn't necessary after 3-4 times that we were constantly there, but we saw that the mix needs to be fine-tuned a bit better than what the producer is usually used to. And so we have to be there on the spot to make the mix as well as possible. we didn't necessarily have to adapt our mix of compressed air blocks towards the producer, if that's a bit the question that you had.
Thanks. Excellent. So we're gonna now Rosa's gonna present. I don't know if you can listen in or how it's working. Yeah. Thank you for your presentation so far. The
Thank
whole
you.
conference will be online later, so you can join in. Otherwise, yeah.
Good to hear.
Yeah. So.